Hello everyone, very warm welcome to all of you on the platform of KSG India. My name is Akhilesh and I am faculty of geography optional over here. Today I am going to discuss few very important topic which is very important for optional point of view, as well as this is something pertaining to your current affairs section and equally important for your general studies section. Today I am going to give you the idea of interior of sun. Then we will try to understand the solar storms, coronal mass ejection, sunspot cycle, etc. We will try to understand in this series of video the impacts of solar storm on the earth surface as well as on the earth environment. These are the very important topic for nowadays because our sun is going through solar maxima phase, and in this solar maxima phase, which is going to be started from 2024, it will end by 2027. So in this solar maxima phase, our earth is likely to receive more solar storms. So in that case, this topic is important. The impacts are going to be important for your mains examination as well as prelims examination. So mark it most important topic, and let's begin today's topic, and I will start with interior of the sun. So we all have this idea that the sun is an average size of star which is having core, and inside the core the reaction which is going on is nuclear fusion reaction, and this is established over here because of the very high temperature of the range 10 to the power 7 degrees centigrade, as we have discussed in previous videos. So this is what core of the sun. Outside the core, the next zone which is there is called as a radiative zone, and then there is convective zone. Fine, this is something pertaining to the interior of the sun. This is what core, where the nuclear fusion reaction is going on. Here it is radiative zone, and this is what convective zone. Convective zone. The topic which we are going to discuss first is interior of the sun. Sun, which is an average size of star in our solar system, ultimate source of energy. Our solar system, the fifth largest planet upon which we are here, the habitable blue planet. The source of energy is what sun, and the sun is containing a core where nuclear fusion reaction is going on, and from here the energy is radiated in form of electromagnetic radiation. It travels through radiative zone, reaching to convective zone, and then the upper surface of the sun is called as photosphere. And then there is a dark surface which is just after photosphere, is called as chromosphere. And lakhs of kilometers away from this sun, there is a zone which we called as corona. The spelling is same as the coronavirus. Indeed, the corona, that means the halo of the sun which is visible normally at the time of total solar eclipse. This corona region is much away from the surface of the sun. As you all have this idea, the sun is made up of hydrogen, helium. Largely it is hydrogen, almost 71.5% of the sun's mass is made up of hydrogen, and almost 26% there is helium, and rest of the 2.5% other heavy elements. Fine. So this is the composition of the sun. So composition of the sun. As you know that these gases Out of these gases, hydrogen is going to be fuel that is involved in nuclear fusion reaction. Nuclear fusion reaction. And this nuclear fusion is responsible for what? The energy the sun is radiating. Okay. So the radiation travel throughout these zone and reaching to the convective zone. Fine. And this is what interior structure. The temperature of the core is 10 to the power 7 degrees centigrade, 1 crore and more. This is the range of temperature you will find in the core. But what about photosphere? Photosphere is having a temperature of almost 6000 degrees centigrade. The bright surface of the sun, that is what photosphere, which is just having 6000 degrees centigrade temperature. Fine. And from this photosphere, if you come almost 1 lakh kilometer or lakhs of kilometer away from the sun surface, you will find region of corona, and you will get to mesmerized that this corona is having very high temperature of the range 10 lakh degrees centigrade. Fine. 10 lakh degrees centigrade is the temperature of corona. And what about the temperature of the photosphere? It is just 6000 degrees centigrade. The source of energy is nothing but sun. And the temperature over the sun's surface, which is closest to the sun, or the surface of the sun, is just 6000 degrees centigrade, while the corona, which is lakhs of kilometer away from this sun, is going to have very high temperature of the range 10 lakh degrees centigrade. This kind of observation is just opposite to the law of thermodynamics. The source is at lower temperature, but the sink is at higher temperature. And what is the explanation? Still it is the matter of debate and research is going on. I am leaving this question to you. Find it out why corona is at very high temperature. I also give you one more clue about that. This coronal heating, problem of coronal heating is not a small problem. It is called as problem of 20th century. Why this corona is at higher temperature despite of the photosphere is at just 6000 degrees centigrade. The source is at lower temperature. Corona at high temperature. What is the reason behind this coronal heating is still a matter of research. There are theories that are explaining it, but not in entirely. So find it out and what is the reason behind it. It is up to you. So comment section में आप लिख सकते हैं. फिर कभी मौका मिला तो इस पे बातचीत की जाएगी. फिलहाल आगे चलते हैं. So this interior of the sun, which is having core, then having radiative zone and convective zone, and this entire mass, most of the mass is what? In gaseous phase, and the maximum contribution is of hydrogen. When this electromagnetic radiation reaches to the convective zone, they cause heating effect, and huge heating occurs in this zone. And due to this heating, what happened? There is genesis of convectional current in the convective zone. What do you mean by convectional current? The strong convectional current. If you have boiled the milk in the kitchen, when mom said, please take care of this milk which is boiling on the small furnace, so you stand over there and थोड़ी सी आपकी नज़र बचती है, दूध गिर के बाहर चला आता है और फिर डांट भी पड़ती है. I think you might have gone through this. So the milk comes out from the pot, a tiny system which is giving you the idea of convectional current that is heated up to 100 degrees centigrade or so. But what happened to these heating which is of lakhs of degrees centigrade? So the heat energy is going to be enormous, and that's why there is formation of convectional current over here. And these convectional current are very strong that it leads to coronal mass ejection. These are the convectional current. And due to these strong convectional current, because of heating, what happened? There is coronal mass ejection, another term which is not at all related with corona, but it is related with sun only, coronal mass ejection. So what happened? These strong convectional current start ejecting out from the earth's surface and going beyond the sun's gravity. And this phenomena contains hot gases plus charged particle plus electromagnetic radiation. Electromagnetic radiation. You all have this idea. Our insolation is consist of this electromagnetic radiation. Electromagnetic radiation, I will refer this with EMR. Electromagnetic radiations, it is a form of energy which is traveling in form of wave. Electromagnetic radiations, fine. It consists of gamma rays, X-rays, ultraviolet rays, visible light, then infrared, far infrared, radio waves, microwaves, etc. So once you go through the spectrum of the light, you will find all these wavelength over there, that is collectively called as electromagnetic radiation. Out of this entire electromagnetic radiation, only visible light is going to be used up on the earth ecosystem, and that is going to be fixed in form of carbohydrate. We will talk it later in the lesson of energy flow, fine. Here, this electromagnetic radiation along with charges and gases ejected out, and this entire ejection is called as coronal mass ejection. Coronal mass ejection. Why this coronal mass ejection have taken place? Because of heating. From where this heat is coming? It is from core. Why? Because there is this nuclear fusion reaction going on, and due to that enormous heat, there is formation of convectional current. Strong convectional current is responsible for ejection of huge mass along with charged particle and electromagnetic radiation. Basically, this is heat, fine. Heat traveling in form of radiation. Heat travels in form of conduction. It can travel in form of conduction, convection, radiation, and the fourth we will read in the climatology, that is what? Advection, horizontal heat transfer, fine. So there are gases, charges and electromagnetic radiation ejected out under the influence of strong convectional current. So what happened? These gases, charges and electromagnetic radiation, they get ejected out from the sun surface, and they start traveling into the space. As it move away from the sun, they get cooled. Cooling means what? Cooling occurs in case of gases. Gases containing mass and rest are massless. So sun's gravity start pulling back the cooled gases because during the course of journey get cooled, fine. So what happened? These cooled gases start falling on the sun's surface. Why it is falling on the sun's surface? Because sun's gravity pulling it back onto the sun's surface, and these cooled gas falling on the photosphere. The bright photosphere is now becoming less brighter. This bright photosphere is becoming less brighter because these are the area where the redistribution of heat is taking place, and due to that it is not at all at 6000 degrees centigrade temperature, because photosphere is at 6000 degrees centigrade temperature. When the cool gases are pouring upon it, there is redistribution of heat and the temperature goes down. So it is almost of the range 2000 degrees centigrade. temperature. So there are many coronal mass ejection taking place. So you are going to have so many such kind of cooler patches present on the sun's surface, basically photosphere. These are called as cooler patches, cooler patch, or it is also called as sun spot. It looks like spot on the bright surface of sun, and that's why it is called as sun spot. Fine. So this coronal mass ejection, I talked about sun spot, I talked about cooler patches. Why this sun spot is going to be there? Because of strong convectional current that led to coronal mass ejection, in which gases are there, charges are there, electromagnetic radiations are ejected out, but it is under the influence of gravity of the sun, gases containing mass, so it is going to be pulled back, and due to these cooled gases, they get cooled during the course of journey for several thousand kilometers from the sun. So once they are falling back on the sun's surface, they have lower temperature, lower heat, and hence what happens, there will be redistribution of heat. The temperature over the area the gases are falling there is going to be reduced, and it will be almost of the range 2000 degrees centigrade, and this looks like patch on a bright surface of the sun. That's why it is called as sun spot. Fine. So this is the explanation of sun spot, coronal mass ejection, and it has various significance. So in next video we are going to have the understanding of this sun spot and what is going to happen with this electromagnetic radiation and charges, because from here the gases are going to be it returned to the sun's surface, but electromagnetic radiation and charges will travel further. This ejection, coronal mass ejection, can also be termed as solar flare. So solar flare, another term you need to understand, solar flare. This is what? Containing hot gases plus charges and electromagnetic radiation. This is what solar flare, which is going to be there, and once this solar flare, the gases get pulled back by the sun's gravity, the remaining part is going to be called as solar storm, which start traveling to the entire universe, and some of the solar storm reaching onto the earth's surface and causing their deleterious impact, which will be discussed later. Fine. So do remember coronal mass ejection, sun spot and solar flare. Thank you very much.